Hello there, ladies and gentlemen. I'll be talking about Le Chatelier's principle today. Okay. Well, you might be asking, what is Le Chatelier's principle? Le Chatelier's principles come from Henri Le Chatelier, a French chemist that was trying to make ammonia in an industrial way. And when he was trying to make it, he came to a conclusion that if you do certain things and if certain things happen, you can create the certain products. And based on his experience and based on his observation, he came up with a new theory and with a new principle, and he called it well, if you make this new discovery, it's going to call after your name. So the principle is called Le Chatelier's principle. Okay. The Le Chatelier's principle is this. It's going to be sound weird, but here it goes. Equilibrium system under stress will shift to absorb the effect of the stress. You might be asking, like, oh, okay, what does it mean? Well, it means this. If you apply a certain stress to a certain reaction, something will happen to that reaction to absorb that stress. Okay? And there are four of the major things about the chemical equilibriums, Le Chatelier's principle, that you should know about. Okay? And the first thing you should know about is change in concentration. Well, what it means by change in concentration, it means this. Adding more of a substance will cause the reaction to make more of the opposite. The opposite also could occur is that the reverse of it will also has the same effect. So what do I mean by this? So for example, let's just pretend that I'm making ammonia by mixing nitrogen and hydrogen. Alright? So right now in a sealed container, I have same concentration of ammonia, nitrogen and hydrogen, just sealed in the box. Alright, but if I put more concentration of nitrogen in the system, the equilibrium changes and it shifts to the side of the opposite. So what's the opposite side of the nitrogen? Ammonia. So what happens if I put more nitrogen? It's going to make ammonia. So the opposite could occur also. So for example, in a closed system we have same amount of nitrogen, hydrogen, ammonia. So if I put more of ammonia in a system, you know what will happen? More of hydrogen and the nitrogen occurs. Okay, so what happens is that in that reaction, the opposite happens. The opposite of everything you put in will be created. So this is the second thing. So you must remember that. Oh, also the other thing is this. You also must remember the molar concentration of each element and each product. So for example, there's 2 moles of nitrate, 3 moles of hydrogen, 1 moles of nitrogen. So you have to remember that these are very important. The second thing about the Le Chatelier's principle, he says, so the first thing he says is like changing in concentration changes the product or the reactant side. So the second thing I should talk about, changing the mole volume or the pressure. Alright, so I should mention that this only affects the gaseous states. Okay, collisions in chemical equilibrium and the chemical reaction itself, what happens is that when there is more kinetic energy, elements, particularly atoms, just collide with each other. But if there is more space, there is less of them to just collide with each other. Alright? So you have to just put this in your mind that this is very important. Sorry about that. So, changing in volume and pressure affects the chemical reaction itself. So let's just give a good example. So we have a nitrogen and hydrogen to make ammonia, alright? So we have 1 moles of nitrogen, 3 moles of hydrogen, and 2 moles of ammonia. Alright? So right now, like I said, as previously, we just have put the same example in it. For example, if I have a sealed container, alright? So if I just put pressure in it, if I put more pressure on it, which side do you think the equilibrium shifts to? Alright, do you think to the left or the right? Okay, so remember that as it says, changing volume will affect the equilibrium. So this is what are you going to do? Is that you have to remember that if there is less pressure in equilibrium, it will shift to the side that needs more. So what I mean by that is this. So 1 here, 1 plus 3 is 4. There's 4 moles in here. How many moles in here? 2 moles in here. So technically speaking, so if I put more pressure into the thing, which side will have more effect of it? Which side will suffer more? Well, the reactant sides will react more. The reactant sides get more effect than this side. All right. So these two reactants will combine each other to make ammonia. Okay. So when there's more gas on this side, we'll shift to the right. So let's just do the opposite. Alright, let's just pretend that we have the same amount of container, but we increase the volume. Okay, we increase the volume. Instead of 1 liter, we have 2 liters of the volume. So what happened? There are more volumes in this reaction. We have 2 moles of here and 4 moles here. What do you think happens? So if there is more space to them, these ammonia gas will disperse. These 2 atoms that combine to each other, the 2 atoms of nitrogen and hydrogen, when there is more space, slowly they disperse to become their natural state of nitrogen and hydrogen itself. Okay, so second thing about the Le Chatelier's principle is this: changing volume will change equilibrium. Not equilibrium, but it changes the chemical reaction and it shifts it to the different side, and whichever side that needs more or less pressure, it will go to that side. Okay, so the third thing I should talk about the Chatelier's principle is the effect of temperature on the system. Temperature change is different for exothermic or endothermic reactions. All right, I could say the similarity between the volume and the pressure and the temperature itself. So, okay, it goes a little bit close to each other, hand to hand. So what I mean by this is this: when you have an exothermic reaction or when you have an endothermic reaction, different things occurs in that system. So what happened is that, imagine we have a reactants and we have products. Okay, so this reaction is an exothermic reaction. So we have reactants to becoming product, and at the end it's going to create more heat. So what happened? If you put more heat in that reaction, in that system, the opposite will occur. So if there is more heat here, this will come this side, so the product becomes reactants. Okay, so if you do the opposite, which is there is more heat in that reaction, when there's more heat in the reaction, if you take away those heat, if you make it cooler, you're gonna make more product. Okay, imagine this: if this heat was here, if this was an endothermic reaction. Okay, so if this was an endothermic reaction, so if your heat plus reactant equals product, so you just forget about this. You know what would happen? So if the more heat you put in, the more products you cause, the more product you make. The less heat you have, the less product you make. So this is the third thing about the Le Chatelier's principle, is that heat has the effect on the Le Chatelier's principle, and more importantly on the constant K number. You have to remember about the effect of temperature. Is very, very important. This is the most important thing about the Le Chatelier's principle between all 4 of them, is this: K changes if heat changes. Okay, this one is very important. Okay, the last thing I want to talk about the Le Chatelier's principle is adding a catalyst. Catalyst speeds up a reaction, but it has no effect on the product. So ultimately, no effect on the equilibrium. All right. So if there's a question comes up and it says like, this is the thing, which one has no effect on equilibrium, you just want to click on or press or type or write on catalyst, because catalyst has no effect on the equilibrium. This is very important. Well, we're just going to talk about a couple of examples to make you understand about more Le Chatelier's principle. So I just made this couple of questions. I hope you can see it. So let's just put this one down, and this one down, this one down, and this one down, so you see better. So we have these two questions. So the question is this. Which way equilibrium shift if you apply more pressure? All right. So imagine we have this. We have silicon oxide. We have sulfur oxide. Silicon dioxide plus oxygen. We have sulfur trioxide. So we have this. So we have SO2 plus O2 to make SO3. So we have this. So if I put more pressure, in that system, which way do you think the equilibrium shifts? Just think about it. So if you put more pressure, the side that it's going to affect on is the side that has more concentration of certain chemicals. So we have 2 moles here, and we have 1 mole here, so we have 3 moles in this side, and we have 2 moles in this side. Okay, so if I put more pressure, which side do you think it will shift? Of course, because it just want to observe and go through it, so this side is going to have more effect. So these two reactions will shift this way. Okay, if I would say, if I told you the opposite question, if I say like instead of apply more pressure, if I say like if I make the volume bigger, which side the equilibrium will shift? It would shift this side, because this thing needs more volume. So if it needs more volume and it gets more volumes, it's going to create more reactants. So this will shift this way. So the second question is this: adding heat in the system. Okay, so if I have, I give you this question, I said nitrogen plus hydrogen to make ammonia plus heat. Okay, so the question is this: if I put more heat, which side does this reaction shift, left to right? So you have to remember that in heat, as I said before, any side the heat is, the opposite side will work. Okay, so heat is in the product side. Which one do you think we're gonna come more? It's gonna produce more of the reactants, because the opposite will occur, because the Le Chatelier's principle says that the opposite of what you're trying to add will become. So if you have more heat in the product side, and if you put more heat in it, it's going to shift to the reactant side. And the opposite is true. If this reaction was an endothermic reaction, if heat was here, and if you put more heat, it will shift this way. Okay, or if you had this, if you take the heat from this side, if this is true, and if you take away heat and makes this system cool down, you're going to create more products. Okay, so that was Le Chatelier's principle. Thank you for listening. You have a great day.